Jupiter, the colossal guardian of the solar system. Imagine a world where storms rage for centuries, radiation belts could kill you in minutes, and a single planet holds enough mass to tug the sun itself into a subtle dance. Jupiter isn't just the largest planet in our solar system. It's a gas giant that shaped the very architecture of our cosmic neighborhood. With NASA's Juno mission still revealing its secrets after nearly a decade in orbit, we're uncovering layers of mystery beneath those swirling clouds. What powers its ferocious storms? What's really at its core? And how does this behemoth protect or threaten the inner planets? And welcome to this deep dive into Jupiter. Let's explore the king of the planets. Jupiter orbits the Sun at an average distance of about 778 million kilometers, roughly 5.2 astronomical units, completing one lap every 12 Earth years. Its axial tilt is a mere 3 degrees, so it experiences almost no seasons. Like Saturn, it spins so fast that it's noticeably flattened at the poles, with an equatorial bulge. This planet is massive. Its diameter is about 11 times Earth's, and its volume could swallow over 1,300 Earths. Its mass is 318 times greater than Earth's, and more than twice that of all the other planets combined. In fact, Jupiter holds nearly all the leftover mass after the Sun claimed its 99.86% share of the solar system. 512. This enormous gravity creates a fascinating effect. The barycenter, the center of mass of the Sun-Jupiter system, lies just outside the Sun's surface. Both bodies orbit this common point. While the Sun dominates, Jupiter's pull is strong enough that our star wobbles slightly. Think of it like two unequal weights tied to a string and spun around. The heavier one barely moves, but the lighter one swings wildly. Here, the string is gravity, and the dance never stops. Jupiter's gravity doesn't just affect the Sun. It sculpts the entire solar system. It acts as a cosmic vacuum cleaner, flinging comets outward or capturing them. And it likely disrupted planet formation in the early solar system. Its influence may even be slowly destabilizing Mercury's orbit over billions of years. Without Jupiter, the inner planets, including Earth, would face far more frequent impacts from wandering debris. It's our unlikely shield. Despite being 5 times farther from the Sun than Earth, Jupiter shines brightly in our night sky, reaching an apparent magnitude of -2.94. It can even cast faint shadows and is a favorite target for backyard astronomers. Through a decent telescope, you can see its colorful cloud bands and the Great Red Spot. Those vivid stripes come from complex chemistry in its atmosphere. Ammonia crystals and other compounds, chromophores, rise from deeper layers, reacting with sunlight to paint the bands in creams, browns, oranges, and blues. The bands are remarkably stable in latitude, but shift in width and intensity. Where they collide, chaos erupts, massive storms and turbulence. The star of the show is the Great Red Spot, a colossal anticyclonic storm, larger than Earth for centuries. First observed in the 1600s, possibly even earlier, it has been shrinking noticeably. Now roughly Earth-sized or slightly smaller, and continues to fluctuate. Its reddish hue likely comes from sunlight breaking down chemicals in its elevated clouds. Recent observations show it's dynamic, wobbling, and interacting with smaller storms that may help sustain it. 2025 Jupiter boasts other storms too, including Red Spot Jr., Oval BA, and massive polar cyclones discovered by Juno, clusters of Earth-sized vortices that defy earlier models. Beneath the clouds lies a layered interior. Jupiter is mostly hydrogen, about 90%, and helium, 10%, with traces of methane, ammonia, and water. As you descend, pressure crushes the hydrogen first into a liquid, then a metallic state that conducts electricity. This metallic hydrogen powers Jupiter's insanely strong magnetic field, about 20,000 times stronger than Earth's at the cloud tops. 2008 Juno data revealed a surprise. Instead of a small, dense, rocky core, Jupiter has a large, fuzzy, diluted core. Heavy elements mix diffusely with metallic hydrogen, extending much farther out than expected. This has reshaped theories of how gas giants form. Winds also plunge thousands of kilometers deep, far beyond what we once imagined. 1017 Jupiter rotates faster than any other planet. A day lasts just under 10 hours. This rapid spin drives its magnetic dynamo and the equatorial bulge. It's not quite a star. It would need approximately 75 times more mass for fusion. But it's the closest thing we have to a failed one in our system. No match needed. There's no free oxygen for combustion anyway. Jupiter has a faint ring system. Discovered by Voyager and studied further since, the main ring is narrow and bright in spots, with fainter outer rings made of dust from its moons. Its magnetosphere is enormous, the largest in the solar system after the sun's. It generates stunning auroras,